In this video, I want to discuss the coordinate system in D-Trix CAD/CAM. Specifically, we are in DCAM Free Design, and I'm in Global System. And you can see the global system here. I'll hover on this work plane, and you'll notice the axis here. We've got the red is the x-axis, okay? And the blue is our y-axis. Green is our z-axis, and the convergence of these three axes is known as the global origin. Okay, so 0, 0, 0 is where they all come together. That's our global coordinate system. Now, in addition to that, each building part has its own coordinate system, and by building part, I mean walls, roofs, floors, okay? As well as individual objects. And by objects, I mean everything else. These panels, okay, this panel, this is one object. This panel is another single object. And even you get in here with these splines, that's an object as well. And each one of these objects has its own coordinate system. Now I'll zoom back out and I will deactivate. And I'm going to show you the coordinate system for these objects. You'll also notice here with the CLT panels that I've selected, it's easy to see the orientation of the panel. You can see that these two that are showing on the ground floor are horizontal in orientation, where the upper story, you'll notice a vertical orientation for the grain of the wood. All right, so each of these has a direction. And you'll also notice here, you can't see the opposite end of these panels right now, but inside, if you look through the windows, there's that gray, all right? So that's also a difference between the interior and exterior of the panel. And that's the way it's being rendered right now, but these renderings are a good clue as to what's going on with the object. All right, so let's talk about the roof system coordinates, because I really enjoy these, and I'll give you a preview just so you see what I'm talking about. I'm in the Building Material Organization System, or MOS for short, and I'm going to select Preview, and when I preview, now I can toggle through and you can see we can pick different elements, but right now I want the roof S4. I'll make that my current and select OK. After I select OK, you're going to notice up here GF1 Wall 8 is going to change to this roof S4. Okay, so that's now the MOS, so any object I create out here is going to be associated with this roof. I'm not creating any objects right now, so that's kind of a moot point, but I just wanted to show where these numbers are coming from. And I'm going to come down here. This is my UCS, or my coordinate system, and I can actually select roof S4 as my current coordinate system. When I do that, you'll see that my coordinates come up for that roof system. You'll notice the X, Y, and Z axis here again, but this time they're at an oblique angle when compared to the global coordinate. All right, completely different coordinate system. Now what's cool about this is I'm going to go into a side view of this. Now I'm on this coordinate system, so if I select side view, there it is, and it gives me a side view perpendicular to that plane. You'll also notice that I'm at a 90-degree angle with this plane. I can do a front view, and again, we're perpendicular to the plane. And I'll just orbit around a little bit so you get a feel for this. And see, now you can see how that's oriented itself. Okay, now this can be a little strange for some of us, but I have to say this is really handy when you're in here modeling on these roof planes, especially when I can get into this says plan view, but I think of this more as a normal view, or a view that is parallel to this plane. So let's get into that view and see what that looks like. So there we see our normal view. So we're looking flat, straight at this plane right now. And this is helpful when we're modeling on the roof or we're trying to cut a hole for a skylight, something like that. It's really nice to be able to come in here and get in a nice flat view so we can measure things and make sure everything's lining up properly. Now, each one of these objects in here, these are called building parts, okay? Every one of these building parts has its own coordinate system, all right? So there's a difference between the coordinate system for GF1, that's my ground floor 1 story, and ground floor 1 wall. So I'm not going to go through each and every one of these, but I want us all to be aware that everything has a coordinate system. I'm going to go back into global 0 now, and I'll choose a southwest isometric view. Okay, and let's look at these objects now. I have CLT panels, and I'm going to use middle mouse and select coordinate system. And this is going to show me the coordinate system for each of these panels that I hover on. So as I hover on this, you see that down here in the bottom corner, we see our X, Y, and Z axis. And if you compare that to the global coordinate system, you see there's a difference in the direction that Y and X are oriented. All right, now let's look at this one over here. Very similar, but remember the 0 point is the convergence of those three axes is different than the global system. If I hover up here, I'm going to zoom in a little bit and look at this axis. So you can see the coordinate system here compared to the global. Now you see the Z direction is parallel with the Y in the global. So this is a vertical orientation of this panel. And that's how we want it to be. And you'll notice all of these are very similar, but they just wrap around the building, in uniform fashion. The other thing, everything has its coordinates in here. Here's a spline. You'll see this beam has a different coordinate system than this panel. If I hover out here, all right. So I'm hoping we all get the idea here that we have to pay attention to direction. And I'll show you where this comes into play. I'm going to isolate just my ground floor walls right now. Okay, and you'll notice the rendering texture that I've chosen for these panels has a different texture for the interior and the exterior panels. Now I like this because it helps me determine what direction things are moving. You can also select, there's a different texture set where these are both the same for viewing purposes. So these are things that will need to be adjusted by the operator. I also want to mention here, I'm going to just orbit around a little bit, that even these little brackets down here, I'll zoom in on that bracket, and I'm going to show the coordinate system for this bracket. So you see it has a coordinate system of its own, and each of the brackets has its own coordinates. Okay, so that's telling the system what direction that object is facing. Now, why is that important, you might ask? Well, I'm going to show you. And I want to get into my wireframe. So here's my wireframe view. And you see I've toggled my axis on. So you can see all my axes here. You can see these two in the horizontal. They have that horizontal axis. Any panel with a vertical orientation obviously has a vertical axis. All right. And now I'm going to start applying processes. And that's really where these coordinate systems begin to have the most effect on our project. So I'm going to choose processes, drillings, and perpendicular to side. Now I want to connect this panel to this panel right here. I'm not going to click on this one, but I want to make this connection, and I want to apply some screws, and I'm going to make some drillings with countersinks, along this panel, and like I said, to connect to that one. So you'll see where we're going here. I'll right click. These are my settings here. You see my diameter, my depth, side position Y. Now what side position Y is from this side that I'm going to choose. I want that to be offset 3 7/16 of an inch. So you'll see where these come into play. The other thing I want to talk about really fast is reference side for drill entry. And right here you see that F is right, and you're wondering, how do you know which is the right side of this? I'm going to click on my little calculating tool here, and it will actually let me toggle through. If you look at the bottom left of your screen, is this correct reference side? And I'm going to right click just to cycle through, and you see this is the bottom, left, top, right. And the reason for this is because of the vertical orientation of this panel. So the F is correct, that's what we want. And I'll select OK. I will choose local array. And now I'll pick my origin and my top. And now you see I'm using the edge between this origin point and the end point as my guide. I'll choose distribute. I want 6 inches from the origin. Again, that's from the bottom. And from that first hole to the next hole, I want 12 inches. I want 6 from the end process down. I want 6 inches. Okay. And 12. And then I want 12-inch spacing all the way. After that, I'll select OK. And you see our holes come in, our drillings. And let me just zoom in here. You can see that countersink. And if I render this panel, we'll be able to see those countersinks come in. Okay, so that's all we wanted. And let's go now to the panel here in the front with the horizontal orientation, and we'll see how we do. So I'm going to choose again processes, drilling perpendicular to side. Select my object, select OK, same settings, local array, my origin. I'll zoom in here so I click on the correct thing, and you'll notice that, let me do that again. I'll click my origin, my end, and you see this edge perpendicular to axis. We get that warning keeps popping up. Why is that? If I come to this edge, I'll have the same result. There we are, edge perpendicular to axis. So if you run into this, and you might wonder what's going on, and on further analysis we'll notice the edge we chose is in fact perpendicular to that axis. So it's not going to apply those drillings. And I think these drillings are mainly meant for beam work, and the CLT panels are much different than beams. So in order to get around this, I'm going to use a logic block. So I'm going to insert my logic block, and I'm in here CLT drilling, max holes 10, and I'll insert. Now I'm going to choose the default values for this logic block. I just click on my button here, and these are the values that I want, and I've copied these right out of that other drilling for this example. So I'm going to select OK, and you'll notice down here in the bottom left, it's asking me for the primary panel. So I'm going to click on the primary panel. It asks, is this correct? Yes. My secondary panel, I want this little panel on the corner that's touching the primary panel. And now you see my drillings come in. And I'll do that on the other side of that panel as well. So now I have drillings on both sides. Let's render this. Okay, and you can see those countersinks coming in there. Okay. Now that logic block will work on vertical panels as well. So here's my vertical panel, and I want to connect to this panel, and you see right there we have our drillings and our countersink is on the outside face. Now that's all great for these ones that are from the outside face of the panel, but what about this one in here? Let me highlight this panel so you can see it. As it relates to this one, I want to drill from the interior face out. So in order to do that, I'll choose my same logic block, insert, and you'll notice up here reference side, F is exterior, D is interior. So I'm going to put a capital D here, select OK, and now I can connect these two panels.